Hello everyone, welcome to the third video for Cumulative Review Packet number 14. We'll be starting with number 18 on this one. Just like number 17, where the first thing we had to do was square both sides, if we look at 18, I cannot move the 16 and cannot move the 1, so I'm going to square both sides to start. And if I do that, these would cancel because they're inverses. We would get 16x plus 1 equals x plus 4 quantity squared. I'm going to write something over here. I've known a lot of students, completely understandably so, look at this and say that the answer is x squared plus 16. I'm going to write a big old yikes underneath that. This is not true. If you write this on your test, I would probably write the word illegal. No, 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 no. So please cross that out. This right here happens if you forget that x plus 4 squared is really x plus 4 times itself. And this is what I mentioned in class, the SAT and SAT is obsessed with. They love putting this on the test to see if you're going to fall for this, but you won't. You won't fall for it. You won't. You're going to be so much better than that. Anyway, so if we actually multiply this through now, we would really get x squared plus 4x plus another 4x plus 16. So the reason I wrote yikes over here is if you had written x squared plus 16, you would have completely forgotten about those poor middle terms there. They would have been so left out. So we have 16x plus 1 equals x squared plus 4x plus 16, or a little bit more simplified, 16x plus 1 equals x squared plus 8x plus 16. Now, just like number 17, I notice I have an x squared in the problem, which means that again, I need to factor and I need this equal to 0, and I want to keep x squared positive. So what I'm going to do is move the 16x over to its like term by subtracting, move the 1 over to its like term by subtracting as well. So I would get 0 equals x squared minus 8x if I combine, plus 15 equals 0. And if I factor this, x times x is x squared, two numbers that multiply to be 15 and add to be negative 8 are 3 and 5, double negative. Negative 3 times negative 5, positive 15. Negative 3 plus negative 5, 'tis negative 8. If I set these both equal to 0, my two answers, possible answers, are 3 and 5. Now, what's really important again is the checking. So if in the original problem, which is the square root of 16x plus 1, does that equal x plus 4? Let's check x equals 3 first. So every time I see an x, I'm going to plug in 3. So does the square root of 16 times 3 plus 1, which is the square root of 48 plus 1, or does the square root of 49 equal 3 plus 4? Yes, the square root of 49 does equal 7, so 3 is in. If I check the second one here, I'll change my color. If I plug, instead of 3 this time, if I take my original equation and plug in 5, does the square root of 16 times 5 plus 1 equal 5 plus 4? 16 times 5 is 80, so does the square root of 80 plus 1, which is, does the square root of 81 equal 5 plus 4 or 9? Yes, it does. So this answer works as well. So this is a quadratic that both answers worked, unlike the previous problem where only one worked, which is why it's so important to check. Number 19, factor completely. Whenever you see factor without solving, the checklist you should think of is the following. First, greatest common factor. Second, perfect squares. Third, if you have a lead number of 1, try to factor quickly. And if nothing else works, then you split the middle. And remember, you want to try to avoid step 4 at all costs. So if I look at 19, the first thing I'm going to think about is greatest common factor. Can I take anything out of all 3? Why, yes, I can. I can take out a 3 at least. And if I do so, I'm left with x squared plus 9x plus 20. And this is quite handy-dandy because now the number in front of my x squared is just 1, so I have a lead coefficient of 1, so I can go straight to parentheses and never mind split the middle. So because I have x squared, I know I can keep factoring. The two numbers that multiply to be 20, that add to be 9, are 4 and 5. So this is my final answer here for number 19, because I am not solving, just factoring. Number 20 as well, what I would suggest is first the greatest common factor. Always check for that. When I look at 50, 60, and 18, I know I can take out a 2. I can't take out any y's though, because this doesn't have a y to take out. So if I do that, I'm left with 25y squared minus 30y plus 9. After I take the GCF out, I look at my second step. Do I have perfect squares? In the previous problem, I did not, because I had a 1 and a 20. But in this problem, I noticed that my ends are 25 and 9. So instead of doing split the middle, why don't we keep the 2, write 2 parentheses, think to ourselves the square root of 25 is 5, square root of y squared is y. So we could write 5y, 5y. Square root of 9 is 3 and 3. To get my middle term to be negative and not cross out, I can't have a plus and a minus because that would cross out. Some of you might recall when I had a negative middle term, both of these ended up as negative. What you could do is always check it, because you have a negative 15y here and a negative 15y here, which does equal negative 30. I would say the best way to write your answer, though, is 2 times 5y minus 3 squared, because this parenthesis happens twice. So again, to reiterate, please, when you're factoring, look at your GCF first and then perfect squares. It usually makes your process a lot faster than split the middle. 21 and 22, both going back to exponent rules from chapter 7. When I see something like this that I want to simplify and I'm dividing, I simplify the numbers, divide the numbers if possible, and subtract my exponents. So first I look at 4/12, and I'm not subtracting, I am reducing. I notice that I can take a 4 out of both of those numbers, so I can reduce that to 1/3. The x's, when you're dividing like bases, you subtract the exponents. So it would be x to the 8 minus 4, y to the negative 5 minus negative 1. Minus a negative becomes a plus, so I have 1/3 x to the 4th power, y to the negative 4th power. It asks me to please not have any negative exponents, so I'm going to keep my 1/3 in front. I'm going to keep my x to the 4th on the top, but my y to the 4th is going to flip to the bottom. I would say the best way to write your answer would be just having 1 times x to the 4th on top, or x to the 4th, then denominator 3 times y to the 4th. So that would be a great final answer for 21. 22, we are multiplying, not dividing, and I notice that I have a parenthesis raised to a power first, so I'm going to apply the 2 to both. Negative 5 squared, x squared, then I'm going to recopy everything else. Negative 5 squared is a positive 25, x squared, y to the negative 8th times 10, x to the 14th, y to the 7th. These numbers are not like bases. The problem asked me to multiply, so I shall. 25 times 10 gives me 250. When I do have like bases, I add my exponents. So I have x to the 2nd times x to the 14th, so that's x to the 16th power, y to the negative 8th times y to the 7th, or negative 7th, I got to bring down that negative, is y to the negative 15th power. Just like number 21, I need to flip this downwards. So my final answer would be 250 x to the 16th over y to the 15th power. I cannot combine these exponents because the bases are not the same. Number 23. This is a system of equations. Now this problem will not be on your final exam. However, I keep reminding you because I know what's coming in geometry. So if I was solving the system of equations, it looks like an elimination problem. So what I would do is multiply this top equation by -2 so that the x's can cancel out. So if I distribute that -2, I would get -4x plus 10y equals positive -2 times 29, 58. I would recopy the second equation down here. I then would combine downwards. These would cross out and combine to be 0. 10y and 7y is 17y. 58 and 27 is a positive 85. If I divide by 17, I get that my y value is 5. And if I would like to find the other value or find x, I would plug it back into either equation. I'll plug it back into this one. 4x plus 7y equals 27. I now know that y is 5. 4x plus 35 equals 27. Subtract my 35. I would get x equals negative 8. Divide by 4. X is negative 2. Y is 5. So that answer as a point would be negative 2, 5. Solving a system is a skill you will need for the rest of your math career. So that's why I put it in this cumulative review packet. Few more questions. Number 24, simplify the polynomials. Please put your final answer in standard form if you can. I put these in from chapter 8 or the beginning of the semester. The reason I put 24 in is I want you to recognize that you are taking a binomial or two terms and you are subtracting, not multiplying, subtracting a trinomial, just for a little bit of vocabulary review. If I'm subtracting, all I'm really doing is taking that negative and distributing it into every single term. So I'd have negative 10y squared minus 3y cubed plus 7y cubed, because of this negative times negative, minus 3y plus 11y squared. The only things that changed were this sign, and this sign. Now, I really just need to combine like terms. I notice these are both like terms because they have the same base and exponent. 7y cubed minus 3y cubed is 4y cubed. I then have negative 10y squared and positive 11y squared. 11 minus 10 is 1y squared. And then the negative 3y has nothing to combine with, so it would just go on the end. And my final answer is in standard form because I have highest exponent down to the lowest. Number 25, the reason I put this on the review was to remind you that everything is connected. This is connected to exponent rules, it is connected to radicals, and everything else we've been doing. If I distribute, what you really want to do is multiply the numbers and add the exponents, just like a lot of things we've been doing lately. So negative 5 times negative 8 is positive 40. X to the third times x to the third, add the exponents, is x to the sixth. Y to the fourth times y to the fifth is y to the ninth. First term, done. Distribute into the second one. Negative 5 times positive 7, negative 35. X to the third times x to the first is x to the fourth. Y to the fourth times y to the fourth is y to the eighth. Last but not least, those. Negative 5 times negative 4 is positive 20. X to the third times x to the first is x to the fourth. Add those exponents. Y to the fourth times nothing is just carried along as y to the fourth. So this would be your final answer, because none of these are like terms because the bases and exponents are not the same. Last but not least, a little bit of exponent stuff, more exponents. Determine the amount of investment of $4,500 if it's invested at a rate of 7.5%, compounded monthly. What this means is you have 12 times a year, and that means that n is 12 times a year. The 10 is the time. This is the A starting value, and 7.5% is the rate, but we write it really as 0.075. So this is the equation we'd have to use. Y equals A times 1 plus R over N to the NT. Let me plug in what I know. My initial value is 4,500. My rate is 0.075. Taking out money 12 times a year, then 12 times 10 years. Y equals 4,500. 1 plus 0.075 over 12 to the 120th power. If you were to get this right, do the order of ops. 0.075 divided by 12 plus 1 raised to the 120th times 4,500 And if you plug that in correctly, your final answer would be $9,504.29.